Welcome to our How To series on SAP Profitability and Performance Management. Modeling Environment, Key Features, Part 2. Before proceeding with our next topic, let us have a quick recap of what has been discussed in our Part 1 installment of Modeling Environment Key Features. We have discussed the function hierarchy buttons such as Add, Remove, Copy, Function Attributes, Activate, and Where Used buttons. Just a friendly reminder to watch first, Modeling Environment Key Features, Part 1, before watching this video. Now that we have already completed the overview for function hierarchy buttons, let us focus on the header button, which are Save, Show Hide, Environment, Historize, and Modeling Flow. Save. Save button has been shown multiple times in Part 1 of Modeling Environment Key Features. But to give a short overview, if there are changes done in the environment, these changes will only take effect once the modeler chooses Save. Also, there is a mechanism that if the modeler doesn't save the changes done in the environment, and moves to another section of the environment, a dialog box will appear asking the modeler if he wants to save the changes done before exiting. If the modeler would choose Yes, the changes performed in the environment will be saved. If the modeler opts to choose No, the changes will be disregarded. As for Cancel, the modeler can continue making changes in the environment. Show Hide. Show Hide button can be used to collapse and expand the function hierarchy to have better visualization of the function details during configuration. Now let us choose the Show Hide button. You would notice that the function details area has been expanded, and would give the modeler more configuration space. Let us make the function hierarchy section available again. Choose Show Hide button. Environment details can be reached via the Environment button, and contain settings that are valid for all functions in the environment. Environment has 6 major sections, which are Environment, Checks, Partitioning, File Formats, Conversion Types, and Advanced tab. For this How To video, let us focus on Environment and Advanced tabs. Since Checks, Partitionings, File Formats, Conversion Types are optional tabs for successful configuration and execution, these will be part of the next installment of videos for SAP Community. Let us go back to the Environment tab. Environment. Fields are the basis for every function and can be divided into 2 major groups of field types. In the first group, the fields are created and managed within an environment. The complete definition of a field, including data types, master data, and hierarchies, are maintained by the modeling user. The fields in this group will be included once an environment has been decided to be imported to a target system via TMS. In the second group, the fields are owned and managed by an external non-SAP or SAP application. The transport mechanism for these type of fields will depend on the transport procedure of the external non-SAP or SAP application. Now that we have an overview of these 2 groups, let us further discuss the specific fields under the Environment tab, which are Environment Info Objects, Environment Fields, BW Info Objects, BW Fields, DDIC Fields, and HANA Fields. Since this section is focusing on field creation, let us run through the different tabs to have better understanding. Environment Fields. In here, the data types are maintained by the modeling user. Fields are visible only in the environment in which the field is defined. Once the environment is transported, these fields will also be available in the target system. As we are on display mode, there are limited buttons, and some are still grayed out to the modeler. To show the other buttons, choose the Edit button. This will now show the modeler the following buttons: Add, Remove, and Copy, as well as the available buttons in display mode, which are Where Used, the grayed out Open Master Data and Hierarchy Data button, and Maintain Attributes button. We will discuss the grayed out buttons in the latter part of the video. For now, let us focus in creating an environment field. Add. This button opens the dialog box, wherein the user can maintain the properties of the field being created. You will notice that there are already created fields in the environment. These fields were used in Part 1 of our Modeling Environment Key Features video. We will now discuss how these fields were created. Let us choose Add. Once the Add Details dialog box appears, the following sections will need to be maintained by the modeler. Field, Description, Field Type, Class, and DDIC data type. Field. Field is a unique technical name that initially has a predefined characteristic value, which can be optionally used or changed to a different value by the modeler. In our case, we changed this to ZE_CURR. Description. Description is a business-like name of the field being created. This has a predefined characteristic value that the modeler can optionally use or change. As we are creating a currency unit field, let us maintain currency as the description of our field. Field type. Field type contains three options wherein the modeler can select what type will be used for the field being created. Characteristic is used to identify key figures and contain text, codes, dates, or numerical characteristic values. Key figure, on the other hand, is used for calculations and can contain natural numbers, integers, decimals, or floating points. While unit is required to give meaning to the values of a key figure. Key figures of the type currency are always assigned a currency key, and key figures of the type quantity are also assigned a unit of measurement. Since we are creating a currency unit field, we selected unit as the field type. For class, there are two options in creating entries in the environment field. It could be a field or a parameter. A field can be used in all functions to work on data. A typical example of a field is a financial period which identifies for which month the data is valid. Parameters are used to steer processes and calculations. Parameters are used in formulas and calls of certain functions to influence the logic and operations applied there. A typical example of a parameter is a flag, which allows a calculation to be skipped or executed in a process. Let us select field. For DDIC data type, the options in this drop list will depend on what field type was selected. As we have selected unit as our field type, the list will be filled with the DDIC data types that are applicable for a unit field. These are cookie, currency for currency field, and unit key of quantity field. Let us select cookie, currency key for currency field. Once we have maintained all the needed values, let us choose OK. Once the field is created, the modeler must maintain the data length, which will determine the length of our field. Before saving, let us maintain 3 as its data length value. Then choose Save. Once this is saved, the modeler will receive a success message indicating that the environment saved successfully. Now let us discuss the other columns in the Environment Fields tab, which are Data Decimals, Unit Field, Master Data, Hierarchies, Hierarchy Name, Lowercase, and Conversion. To have a better view of the different columns, let us choose Show Hide to expand the function details. Now that we have a better view, let us discuss about them further. Data Decimals. The modeler will need to maintain this column if the field is of type key figure that requires a decimal notation, such as DEC, packed number in BCD format, and CUR, currency field in BCD format. Let us select field ZE_AMT, which is a CUR, currency field in BCD format. Then choose the drop list in the data decimals column of the field. In the drop list, you will notice that the data decimal has a maximum value of 15. This is the maximum length that can be used as a value for data decimals. In our how to video, we have maintained the data decimals to 2 for field ZE_AMT. Unit field. If the key figure created was of type currency or quantity, the unit field should be maintained by the modeler. This will assign the unit field to a key figure field. The drop list would be enabled for the unit field column if the key figure is of type currency or quantity, and will show the modeler the list of possible unit fields to be assigned for that key figure. In our example, we maintain the created ZE_CURR currency unit field to our ZE_AMT currency field. Before we proceed to the master data and hierarchies column, let us select field ZE_PROD first, as only characteristics are allowed to contain master data or hierarchies. When a modeler needs to define a master data or hierarchy for a field, these columns should be marked. Once these columns are marked, you will notice that both Open Master and Hierarchy Data and Maintain Attributes button are enabled. This will give the modeler the capability to maintain the master data by choosing Open Master Data and Hierarchies button. Now let us create the master data and the hierarchy for our ZE_PROD field. Choose Open Master Data and Hierarchies button. A new window will open where you can maintain the master data and the hierarchy for field ZE_PROD. In our example, we have maintained the following master data and hierarchy for our field ZE_PROD. Then we choose Save. Once this is saved, the modeler will receive a success message indicating that data entered was saved successfully. The modeler can now use the master data in defining what values can be maintained for that field, and can use the structure of the hierarchy created. But before exiting the window, let us remember the hierarchy created in this step, which is MAT_HIER. Now let us go back to the Environment tab. From here we proceed to the next column, which is Hierarchy Name. In this column, the modeler can maintain the created hierarchy of the field, so that the modeler can use this hierarchy when structuring the data in a query. The discussion in using hierarchies in a query will be part of the next installment of videos for SAP Community. Let us maintain the created hierarchy earlier under the Hierarchy Name column. Now that we have maintained MAT_HIER for field ZE_PROD, let us proceed with the last two columns. Lowercase. By default, the environment fields created are on uppercase format, and to make the data records accept lowercase entries, this checkbox should be marked. Conversion routine. Conversion routines are used so that the characteristic key values of a field can be displayed or used in a different format to how they are stored. The most common used conversion routine is alpha. For our how to video, let us leave this column as empty. Now that we maintain the needed entries in creating a field in the Environment Fields tab, let us choose Save. Now that we know the different sections in creating a field, let us go back to the different buttons that we have yet to discuss. These are Remove, Copy, Where Used, and Maintain Attributes. Copy. By choosing the Copy button, all properties of the selected field will be copied automatically. But before doing so, choose the field to be copied. In this example, we choose the field ZE_PROD. Choose Copy. The Copy Details dialog box appears. Here the modeling user can choose what position will the field be copied below. In our example, we have selected below row 3. This will create the copied field below ZE_CURR field. In the table below target position, you will notice that there are two pairs of field and description. On the left side, this is the field being copied, while on the right side, this is the field name and description for the copy of the selected field. In this video, let us maintain ZE_MAT as the field, and material as the description. Then choose OK. Once the field is copied, you will notice that the properties of ZE_PROD is copied to ZE_MAT. To officially save the field in the environment, let us choose Save. Now when a modeler would need to remove a field that is no longer relevant in his environment, the modeler would need to select the field to be deleted, and must choose Remove. In this how to video, let us remove the newly copied field which is now selected. Then choose Remove. Same as how a function is removed. Once this Remove button is chosen, a Confirm dialog box will appear. Here we leave the comment section blank, and choose Confirm. To officially save the deletion of the field in the environment, choose Save. When a modeler would like to check if what function a field is used, the modeler can select a field and choose the Where Used button. In this video, let us select ZE_PROD, and check what functions uses this field. By choosing the Where Used button, a dialog box will appear. In this dialog box, we can see where the field ZE_PROD is used in our environment. Optionally, you can be redirected to the function that is currently using the field by choosing the function ID. For example, MTPRD. A new browser window will open and will display the function details of the chosen function. Let us close this window and go back to the Environments tab. Maintain Attributes. In this button, the modeler can opt to use the master data of a different field that is created within the Environments tab. As we have no other fields that contains master data, this screen will appear as a blank field list. Only when a modeler creates another field containing master data will this list be filled. Now that we have discussed the different buttons and properties for the environment fields, we shall be discussing the other tabs within the environment. Let us proceed with Environment Info Objects. In here, data types, master data, and hierarchies are maintained by the modeling user. Fields can refer to other info objects that share metadata. Once the environment is transported, the objects created for this field will also be generated in the target system. Please take note that the buttons Remove, Copy, Open Master Data, Open Hierarchy, and Where Used are similar with the mechanism of the buttons in the Environment Fields tab. So let us just focus on adding an environment info object. To do this, choose the Add button. The Add Details dialog box appears where you have to maintain the following: field, description, and field type, which we already discussed earlier in this video. Now let us maintain these three sections. Reference info object. The modeler can opt to use the attributes of an existing info object in the system, so that the field would be able to share the properties and metadata of that info object with the field that we are creating. In this example, let us choose an existing product info object. Choose the F4 Help. A search dialog box will appear where the modeler can search for info objects that are available in the system. In this how-to video, let us search for ZQA_PROD. Choose Search. Choose ZQA_PROD in the item list. Info object is a 10 alphanumeric field that must start with a letter Y. The maintained value in this section will be name of the generated BW info object. Let us maintain YZE_PROD in this section. Choose OK. For the environment info object to be officially created in our environment, choose Save. You will notice that upon saving, the different properties of the field was maintained, such as BW data type, data length, conversion routine, master data, and hierarchy columns. These properties were shared from the reference info object to the created environment info object. Also, the modeler could opt to utilize the functionality of hierarchies by maintaining the following sections: hierarchy name, hierarchy version, hierarchy assignment, and hierarchy date. Using the same steps, we have created field YZE_AMT. But this time the reference info object was not maintained. This means that the modeling user will need to maintain the properties, similar to what we have done in the environment fields. Now we have maintained the BW data type as currency in BCD format, and key figure type of amount for our field. As for aggregation, this is applicable only for fields which are of type key figure. In the drop list, the modeler can use maximum, minimum, or summation as the aggregation level for this field. In our video, let us select summation. Now that our currency field is ready, please take note that it's mandatory to link a unit field into it. To fast forward, a unit field YZE_CURR will be created using the same steps. Then choose Save. Now that we have already discussed the different buttons and properties for first group of fields in the Environment tab, let us proceed in discussing the second group. For BW info objects and DDIC fields, the modeling user can add a field from an external source by choosing the Add button. In our video, let us focus in adding a DDIC field in our environment. Choose Add. The Add DDIC Fields dialog box appears, where the modeling user can search for the list of DDIC fields that are available in the system. In our video, let us search for DDIC field ZQA_PRODUCT. Then, choose Search. Once the search is finished, the list of fields matching the search criteria will be displayed. From here, the modeler can select the field from the list and choose OK. The DDIC field chosen has now been added to the list. Let's now proceed with BW Info Objects tab. You will notice that the buttons in these tabs are the same as what we have in our Environment Info Objects tab. To fast forward, we have only focused in adding a BW Info object using the same steps performed in the DDIC Fields tab. Now we have finished discussing on how to consume external fields, such as BW Info objects and DDIC fields. Let us proceed with BW fields and HANA fields. The only way to add fields in these tabs is by consuming an info provider for BW fields, or a HANA table for HANA fields. The consumption of these fields will be part of the next installments of our SAP community video. From here, the modeler has the option to remove the field and to trace where the field is used via the Where Used button for HANA fields and BW fields. In addition, the modeler can view all of the fields from the different tabs by going to the All Fields tab, wherein the modeler can perform a consistency check and trace where the field is used via the Where Used button. Let us check if we have inconsistencies in our environment by choosing the Consistency Check button. A message would then appear with information that there are no inconsistencies in the environment. Now that we have discussed the different tabs in the Environment button, let us proceed with the Advanced tab. In the Advanced tab, here you need to register the NetWeaver database connection to the underlying SAP HANA database. Since a user and password is always attached to a DB connection, it indirectly specifies the authorizations and therefore which data and views are available. By default, this is the standard DBCON connection. Callback RFC destination, and the RFC destination allows the modeler to connect an SAP ERP or SAP S4 HANA system to SAP Finance and Controlling. If this is set, the remote function adapter can post documents to an S4 HANA system or replicate master data from it. For example, using remote function adapter type replicate CO master data. This replicates master data and hierarchies for specific and main controlling module fields from a remote system back to SAP Profitability and Performance Management. The discussion about remote function adapter will be part of the next installment of videos for SAP Community. Now this concludes our discussion of the Environment button. Let us proceed to the two remaining buttons, which are Historize and Modeling Flow. But first let us choose Show Hide button to collapse our function details section. Historize. Once a modeler chooses the Historize button, all of the configuration and fields created in the environment will be stored in our modeling history application. This helps the user to trace and audit who did what and when. Depending on the user authorizations, even historic versions of environments and functions can be restored. The discussion about modeling history will be part of the next installment of videos for SAP Community. Modeling Flow. Once this is chosen by the modeler, the Visual Modeler application will open in a new window. This shows a visual representation of an environment version in the form of a directed graph, where you can see the dependencies between business functions. The discussion about Visual Modeler will be part of the next installment of videos for SAP Community. Now we already completed the overview for the header buttons. We hope you learned the basic features of the modeling environment. Thank you for watching. Find more videos about SAP Profitability and Performance Management on this channel. Visit sap.com for more information, or contact your local SAP account executive for a system demo.